Hi, my name's Vicky Ramsey and I've been studying physics since 2006. In episode 1 of my ENA video series, I talked about general relativity in relation to the calibration of atomic clocks, and how the theory of general relativity denotes that clocks tick slower on the bigger mass, where, via the principle of mass-energy equivalence and the equation E = mc squared, an atomic clock should then require more energy in order to tick slower at a lower frequency, and less energy in order to tick faster at a higher frequency. When in practice it is my observation, via the mechanics of atomic clock calibration, that the reality is the exact opposite. And the atomic clock actually requires more energy in order to tick faster at a higher frequency, and less energy in order to tick slower at a lower frequency. Where to say so, my observation is in keeping with the fact that energy and frequency are proportional. And I talked about how, if I am right about an atomic clock requiring more energy in order to tick faster, general relativity would have to be amended to state that clocks tick faster higher up within a gravity potential, and clocks tick faster in the greater gravitational field. I want to talk here about this modification of general relativity in relation to the general relativity equations. So, to give a bit of background, the general relativity equations are dynamical. In the year of 1917, Einstein's theory of general relativity, when applied to the universe we observe, predicted that either space is expanding, causing all the stars to move apart from one another as if from a gigantic explosion, or space is contracting. This would cause all the stars to ultimately collapse upon one another. Einstein's response was to add a mathematical term that he named the cosmological constant to the left side of the equation in order to describe a static universe in equilibrium. In the year of 1917, according to Einstein, the universe should be neither contracting nor expanding. He later went on to describe the addition of this cosmological constant as being his biggest blunder. This being because in the late 1920s, Hubble discovered that there is a proportionality between the degree of redshift from the light of stars in relation to the distance the star is located with respect to our solar system. The further a star is away from our solar system, the greater the observed redshift. Therefore, in applying the effect of a Doppler shift of light to these redshifts, the further a star is, the faster it is moving away from the observer. So, as a point of logical progression, it was determined that the universe must be expanding. Einstein considered that he had made a blunder because his equations had actually predicted a dynamical universe. He consequently retracted his addition of the cosmological constant from the general relativity equations. And Hubble's redshift distance observations went on to become the catalyst for what is now known as the Big Bang theory. Okay, so Hubble's observations were interpreted as being the Doppler shifts of light, caused by distant light sources moving away from our solar system, where the Doppler shifting of light sources due to relative motion between light source and observer had been known since the mid-1800s. There is, however, another type of shifting of light known as gravitational shift. This was first proposed by Einstein from his thoughts in the development of general relativity in 1907, and has since been verified by experiment. Light travelling in a gravitational field will be redshifted when moving away from the mass into a lesser gravitational field, and blue shifted when moving towards the mass into the greater gravitational field. Nevertheless, because it is thought that the voids of empty space between galaxies and galaxy clusters have zero or otherwise negligible gravity fields, the gravitational shifting of light is then thought to be only a minimally contributing factor to the redshift observations. And, to complete the relevant background here, Einstein's general relativity also resulted in the prediction of gravitational waves. The actual existence of gravitational waves was first demonstrated in the 1970s by Hulse and Taylor, and are now directly observed by LIGO and other gravitational wave detectors since 2015. Gravitational waves travelling through space carry energy, and the stronger the gravitational wave is, the more energy it carries. So, to recap, general relativity predicts that clocks tick faster higher up within a gravity potential. And it is indisputably proven by experiment that clocks do tick faster positioned higher up within a gravity potential, where the gravity is lesser, as compared to a clock placed closer to the gravitational mass. And finally, just a quick reminder that in episode 1, I provided a GPS engineering timedilation.gov paper showing that an atomic clock is operating at a lower frequency when ticking slower and at a higher frequency when ticking faster. What I wish to discuss here is the notion that an atomic clock requires more energy in order to tick faster at a higher frequency in relation to the general relativity equations. I am now going to outline, on the basis that a greater gravitational field has more energy, how the general relativity equations themselves do not need to be changed in order to describe a clock requiring more energy in order to tick faster, and how it is only the interpretation of some of the general relativity predictions that would require alteration. So, does a gravitational field have energy? On the basis that the mass causing a gravitational field has energy via the equation m equals E divided by c squared, and that gravitational waves carry energy via gravitational radiation, noting that we already have the notion of a vacuum energy that is, however, plagued by the cosmological constant problem, it's not actually a huge leap of the imagination to suppose that the spaces between bodies of mass have energy that could be thought of as being anisotropic and proportional to the fall-off of gravity in the field, where the inverse square law reduces gravitational field strength with distance from mass. It is relevant here how John Wheeler summed up the theory of general relativity in these 12 words. Space-time tells matter how to move. Matter tells space-time how to curve. Where matter and space-time are viewed as separate entities that each have their own roles of action, and that these separate roles of action are operating concurrently to each other. Bearing these thoughts in mind, I'm now going to introduce 6 operations of modification to the current interpretation of general relativity. Operation 1. Add to general relativity the axiom plus energy equals shorter seconds. Operation 2. State the energy density in space to be anisotropic and reducing in density with distance from the gravitational mass. Operation 3. State clocks as ticking faster higher up within a gravity potential and as ticking faster in the greater gravitational field. Think bigger galaxy here. Operation 4. Add to general relativity the axiom shorter seconds for mass equals plus electromagnetism, where plus electromagnetism for a mass positioned further up within a gravity potential of a gravitational mass creates more attraction/momentum tending towards the gravitational mass, which would in fact be offset by the increase in centrifugal force caused by the increase in centripetal speed found at the greater radius. But I think I'll make that a subject for another day. So, Operation 5. State a separate, i.e. additional, hidden time dimension for where m equals 0. Or, in other words, state a hidden time dimension for the spaces between bodies of mass that occurs independently from, but concurrently to, the time dimension for mass. I say hidden because all physical clocks are comprised of energy in the form of mass and are observable, where this additional time dimension for space would be purely energy related, and therefore not measurable except by observation of effects. The observation of effects being where m equals 0, i.e. open spaces, seconds tending to shorter with increasing proximity to the gravitational mass, caused by the energy of space increasing with increased proximity to the gravitational mass, create a directional and increasing momentum for a mass little m moving towards the center of the gravitational mass big M. Operation 6. Bearing in mind that the speed of light is a distance held relative to the length of a second, add to general relativity the axiom the speed of light cannot exceed the local rate of time. Now, to say so, adding these 6 operations of modification to the current interpretation of general relativity are fully compatible with and do not change the general relativity equations in any respect. Point of fact, what this regime initiates is a completely new means of describing what gravity does, inclusive of gravitational lensing via cause and effect mechanics. This being something that neither general relativity nor the Newtonian mechanics that general relativity supersedes is capable of achieving. But, and this is a big but, what this regime also does is completely change the outlook for the cosmological model. In episode 3, I will be making an introduction as to how these modifications to the current interpretation of the general relativity equations changes the outlook on cosmology. Meanwhile, I have left relevant links in the video notes pertaining to all of the aspects that I've discussed today, including my more detailed article further outlining these 6 operations of modification to general relativity. Thanks for watching.